Welcome everyone. In this video lecture, I am going to discuss the detection of ultrasonic waves and its applications. In the previous two video lecture, I talked about introduction of ultrasonics, its properties, and the production of ultrasonic waves. And then I discussed about magnetostriction method of production of ultrasonic waves and the piezoelectric method to produce ultrasonic waves. Now, coming to the detection of ultrasonic waves, there are actually a variety of methods to detect the ultrasonic waves. An ultrasonic level or sensing system requires no contact with the target. For many processes in the medical, pharmaceutical, military and general industries, this is actually an advantage over inline sensors that may contaminate the liquids inside a vessel or tube or that may be clogged by the product. So first we will talk about the piezoelectric detector. The piezoelectric detector or the piezoelectric transducer is a very important part of an ultrasonic instrumentation system. As I have discussed in the previous part, that is where I discussed about the production of ultrasonic waves, a piezoelectric element can convert electrical signals into mechanical vibrations. So that is actually the transmit mode if you think about a transducer, and the mechanical vibrations into electrical signals, that is actually the receiving mode. So a piezoelectric effect can be used to detect ultrasonics. So if ultrasonics comprising of compressions and rarefactions are allowed to fall upon a quartz crystal, a certain potential difference is developed across the faces, which after amplification by an amplifier can be used to detect ultrasonics. So what you can see here, it is a cutaway of a typical contact transducer. So here this is actually the piezoelectric element, and then this is actually the ultrasonic waves, which is comprising of compressions and rarefactions, and this is actually allowed to fall on the quartz crystal. The piezoelectric element, that is the quartz crystal in this case, is cut to half of the desired wavelength. And then we use some kind of backing materials, and the backing material supporting the crystal has a great influence on the damping characteristics of a transducer. And then there are some other electronics to amplify the signal and to detect the ultrasonics. Also, we can use Kunz tube to detect the ultrasonic waves. Kunz tube is actually an experimental acoustical instruments invented in 1866 by German physicist August Kunz for the measurement of the speed of the sound in a gas or in a solid rod. But it is also used today for demonstrating standing waves. The tube is a transparent horizontal pipe which contains a small amount of fine powder, such as you can use lycopodium or cork dust. So basically it is a long glass tube supported horizontally with a air column in it. When the ultrasonic waves are past the Kunz tube, the lycopodium powder sprinkled in the tube collects in the form of heaps at the nodal points and blown up at the antinodal points. So what we do here, when the ultrasonic waves are passing through the Kunz tube or passing through this tube, so we try to adjust this disc so that the resonance can happen. This means the length of the round trip path of the ultrasonic waves from one end of the tube to the other end and back again is a multiple of the wavelength lambda of the ultrasonic waves. Therefore, the length of the tube is a multiple of half a wavelength. So at this point, the ultrasonic waves in the tube are in the form of standing waves, and the amplitude of vibration of air are zero at equally spaced intervals along the tube, and we call these as nodes. So here the nodal points or the nodes are denoted as N and the antinodes are denoted as A. So as the air is still and quiet there, the powder is caught up in the moving air and settles at little piles or lines at these nodes. The distance between the piles is 1/2 wavelength, that is, if you think that the wavelength is lambda for these ultrasonic waves, so the distance between these piles is the half of the wavelength of the ultrasonic waves, that is lambda by 2. So by measuring the distance between the piles, the wavelength lambda of the ultrasonic waves can be found. Also, we can detect the ultrasonic waves using sensitive flame method. So, when a narrow sensitive flame is moved in a medium where ultrasonic waves are present, the flame remains stationary at antinodes. At the positions of nodes, the flame flickers because there is a change in pressure. In this way, positions of nodes and antinodes can be found out in the medium. The average distance between two adjacent nodes is equals to the half of the wavelength. Also, there are thermal detectors to detect the ultrasonic waves. So, this is the most commonly used method of detection of ultrasonic waves. In this method, a fine platinum wire is used. This wire is moved through the medium at the position of nodes. Due to alternate compressions and rarefaction, adiabatic changes in temperature takes place. The resistance of the platinum wire changes with respect to time. This can be detected with the help of a meter bridge arrangement. At the position of the antinodes, the temperature remains constant. This will be indicated by undisturbed balanced position of the meter bridge. And again, this between two nodes, the difference is actually lambda by 2. Now, coming to the applications of ultrasonic waves, we can use ultrasonic waves to detect the flaws in metals. This is actually a non-destructive testing. We use non-destructive testing, and this is actually a commonly used method to find flaws in materials and to measure the thickness of objects. Frequencies of around 2 to 10 MHz are common, but for special purposes, other frequencies are used. Inspection may be manual, or you can do it as an automated way. And this is actually an essential part of the modern manufacturing process. Most metals can be inspected as well as plastics and the aerospace composites. And normally we use lower frequency ultrasound like 50 to 500 kHz to detect or inspect less dense materials such as wood, concrete and cement. So what we do here, we send out ultrasonic beams, and by measuring the time interval of the reflected beam, flaws in the metal block can be determined. So basically, when there is a flaw or some void space in the metal, so you can see here, so there is a void space or flaw in this metal. So a flaw or a void in the solid material reflects some energy back to the transducer, and which is detected and displayed in the CRO signal. So this is actually the CRO signal of a perfect metal. So where you can see just two signals, and this is the CRO signal of the cracked material. So you can see here an extra CRO signal, which is just because of the void space. Also, we can use ultrasonic for the drilling purpose, and this is actually called ultrasonic drilling. Ultrasonics are used for making holes in very hard materials like glass, diamond, etc. For this purpose, a suitable drilling tool bit is fixed at one end of the powerful ultrasonic generator. Normally, the drill uses a piezoelectric actuator as its source of power and utilizes a variety of horns to vibrate or hammers its bead through the material. And then some slurry, which is actually a thin paste of carborundum powder and water, is made to flow between the bead and the plate in which the hole is to be made. So these are actually the paste of carborundum powder and water. Now, ultrasonic generator causes the tool bead to move up and down very quickly, and the slurry particles below the bead just remove some material from the plate. This process continues and a hole is drilled in the plate. Also, we can use ultrasonic waves for the green energy purpose. Piezoelectricity, being non-polluting, is called green energy. It can be an alternative green energy source in providing piezoelectric flooring at places such as floors, airports, shopping malls, train stations, or places where heavy foot traffic is available. We can use ultrasonic waves for the dispersion of fog. Fog is defined as a mass of water vapor condensed into small water droplets on powdery materials made from smoke, tires, etc. When ultrasonic waves directed towards fog, they being longitudinal in nature get reflected from its constituents and form stationary waves. The stationary waves, comprising of high and low density points, help coagulate the liquid and the solid particles in the fog, turning them into big particles. These particles fall on ground due to the gravity, resulting in dispersal of fog. Also, we use ultrasonic waves for the car airbag sensors. Powerful ultrasonic waves detect intensity of the shock and send an electrical signal to trigger the airbag. Also, ultrasonic sensors are used to determine the position of front seat passengers. What you see here in this picture, this is actually a Jaguar car. So basically, Jaguar engineers are using 4 ultrasonic sensors to determine the position of front seat passengers. And this type of occupant classification is actually used to determine if it is best to deactivate or activate airbag deployment for the small and out of position riders to avoid injury. Also, we use ultrasonic waves for the sonar technology. Sonar is a technique which stands for sound navigation and ranging. It uses ultrasonics for the detection and identification of underwater objects. The method consists of sending a powerful beam of ultrasonics in the suspected direction of water. By noting the time interval between the emission and the receipt of the beam after reflection, the distance of the object can be easily calculated. Now, measuring the time interval between the transmitted pulses and the received pulses, the distance between the transmitter and the remote object is determined using the formula d is equals to v into t by 2, where v is the velocity of the sound in seawater. Also, we use ultrasonic waves for medical imaging. Medical sonography or ultrasonography is an ultrasound-based diagnostic medical imaging technique used to visualize muscles and many internal organs, their size, structure, or any pathological lesions. So here, this is the ultrasound of human heart showing the 4 chambers. So in this video lecture, what we learned, the detection of ultrasonic waves and different applications of ultrasonic waves. So that's all about ultrasonics or ultrasonic waves.